Within the field list, we have seen how to generate fields, combine them, remap them, and how to modify a number of parameters. Additionally, we can add some adjustments and secondary effects within the field's layer stack and post-process the existing data. We do this using a number of special fields. In this video, we will talk about the modifier field layers. Let's begin with the clamp modifier. I'm going to select my generic matrix and add a plane effector. And you can see that they are all here in alphabetical order. Now, because these are modifiers, they need something to modify. So what I'm going to show you applies to all except for the freeze. Okay, so we'll deal with this a bit later. So let's begin with a clamp. Now let's create a linear field. And you can see we have this nice linear ascension of values from 0 to 1. Now if I go and add a clamp, nothing happens by default, but I can go and clamp the values like this. So whatever the values are underneath the clamp can be clamped within this range. Fantastic. Now the clamp min and clamp max switches don't do anything with them, because if you do, they just won't apply any clamps because we're unclamping the clamp. And where's the fun in that? Anyhow, so that's the basic idea. At any part of your field list and with any values you have, you can just set a clamp modifier to clamp the values. And just to make this a bit more interesting, I'm going to add a random field, drop it underneath here. I'm going to set my randomization type to noise. I'm going to increase this so it becomes nice and noisy, and turn off the view settings. And you can see that without the clamp, we can see the noise, and with the clamp, we get the noise which is cut. And we can chop all sorts of different parts of this and create some interesting effects. You could do this on a per field basis by controlling the remapping, but if you want to do it on a part of the list, then you do it using a modifier. And that's what the clamp modifier is for. The color filter is a very particular filter. It does just a couple of things. I'm not going to get into super detail about the settings, but I'm going to show you quickly what it does. So for this, I've created a cloner with some cubes. I've added a plane effector that only affects the color, and in the plane effector fall off, I've added a shader field with this beautiful image here. Fantastic. Now, if I add a color filter, you will see that suddenly it goes black, and there's a reason for this. Because I've told the plane effector only to use the colors, if you go here and select the color filter, you will see that the source is the value, and values are these little buggers here. Now, if I change this to color, then it will only deal with the color. But we can do this for color and values, but colors make more sense. And immediately you get this monochrome effect based on this color here. And the color filter, all that it does is provides us with a simplified way to create either a monochrome image or a duotone image. Now, so that for the monochrome, the simple rule is that where we have about 50% lightness, we get 100% of this color. Below that, we get an addition of black, and above that, we go towards white. So we create these nice little monochrome effects between a color and a mix of black and white. And I don't know how you're going to use that, but you're the artist, you will know better. And as far as the duotone effect, there's a bit of a misnomer here. So the top color actually is the base color, and the base color is the color on top. I don't know why. There must be some scientific way I do not understand, but anyhow. And we have the ink densities and that kind of stuff. So let's go to the base color and put a blue color, and let's go on top and create some sort of, I don't know, orange color. And by playing with the densities, you control how much of each color comes in front. And then we have two different dyes, the opaque, which is like some sort of poster prints, I think, some sort of silk screening. With silk screening, you get opaque colors, and this is that mode, whereas a dye, which is your normal CMYK printing, you get these colors. Anyhow, I'm not going to say any more. This is what it does. It does monotones and duotones. The colorizer just colorizes the colors, just like the colorizer shader. So if I add it here, you will see that nothing happens, and there are a couple of reasons for that. Number one, the source, we need to set it to color. And the second thing, because this looks a bit odd, I think this is some sort of glitch, but you need to open this, go to Edit Alpha, and remove the black knot, because there's a gradient alpha here, which we don't really want. So now that we've removed the alpha essentially, what I'm going to do is turn off the Edit Alpha, and let's add some sort of gradient here. So we can go to Load Preset and load the German flag. And there you go. Anything that's on this side maps the black colors, anything on this side maps the white colors, and everything in between gets these colors. So let's load another preset, and here is Rainbow Me. And that's what the colorizer does, just like in any other image manipulation software. One thing I need to note, which should be obvious by now, but anyhow, you can see that the colorizer and all those modifiers that only affect the color do not have a value. So although they can read the value and interpret it as color, they do not output value. So the colorizer will only modify the colors. And you can see that it's missing the little squiggly sine wave over here. The same principle applies to all other modifiers that have one or the other missing. The curve modifier does exactly what a curve adjustment does to a bitmap image. So let's go and add it, curve, and let's turn on colors. And basically I can use this curve to remap the colors. So we can actually do things like offset the whole curve or offset using animation. Now if I set this to 90, and I've set my time to 180 frames, if I click play, nothing will happen. And the reason is not relating to the curve. Just don't forget that if you have a shader field, in order for any of the values of the shader field to animate and refresh, we need to go to the refresh group here in the field tab and click on frame. Now if I go to the curve and press play, you will see that we get this animated offset. Now the whole thing goes white because you can see that before curve it clamps here to 0, and after curve it clamps here to 1. So everything's going to become 1, which means every value is going to become white. So what you can do, and let's go and add something interesting. I'm going to right click in my little GUI and go to spline presets and get a sine wave. And what I need to do is make sure that we have a loop before and a loop after. And now, because we have loops before and after, you can see that this whole thing is going to loop. And the great thing about this is that we can use this with values as well. So let's go to parameter, let's add some position, and you can see that now we get a beautiful thing that's funky, and it's looping at the same time. The decay modifier, and let's go and add a plane effector to this, allows us to do the following thing. Now, in order to set this up, I'm going to create a very simple field animation. I'm going to go and grab myself a spherical field, and I'm going to go to my remapping and make it really round and make it a bit smaller. And finally, I'm going to add a vibrate tag, and in the X, I'm going to put 400, and in the Z, I'm going to put 400 and set the frequency to 1. So let's press play, and you can see that the field is moving around and it's erasing these little matrices, these little cubes. So if I go to the plane effector field list and add a decay, you can see that it leaves a tail behind. Now the decay field allows us two modes, the maximum and the minimum. And although, as Maximum claims, you will use maximum most of the times, I'll tell you what they do. The maximum value is actually how much time it's going to take for these to go to their original position, so lose their value. Whereas the minimum is how long it's going to take them to go from the original value up to the value that anything underneath tells them to. So basically, this will be, the maximum will be the echo or the tail end if we were dealing with sound, whereas the minimum would be the attack, basically how long it takes to actually reach the full value. And we can always control the effect and have a bigger tail. If you maximize this, then they will stay up forever. And because we can see we have an extra little tab that says effect strength, you can guess that underneath here we have a subfield. So the parameter effect strength we can control this by using fields. So maybe you want to have the fields on one side go faster than the ones on the other side, and you can create this interesting effect because now the field in here is controlling this parameter. If I maximize this, fantastic. Need to bring it down a bit. If I minimize this, then you can see that these are very slow, but everything else falls quite fast. Anyhow, whenever you see an extra tab, that means that in here you can put fields to control the parameter which is named on the tab. For the delay, I'm going to use the same scene. I've extended my frames to 300, and let's go and add a delay. And you can see that we get something that kind of looks similar, but not quite. So let me show you what that does. Let's go to the layer, and we have the smooth mode, which actually smooths the values as they come in and as they go out. It's just like combining two decay fields, but I can put it in linear, which actually makes the progression linear rather than ease in, ease out, which is with a smooth. And of course, the very interesting spring. And you can see we get this springy motion. Now, because with spring, especially when our clones are placed on the 0 plane, because our list is clamped, they will not be allowed to spring downwards. So when you're using spring with rotations or positions, just uncheck this, and now we will see the springy motion in all its glory. And of course, we can turn on the colors as well, and they will be springy as well. The formula field is very simple in the way it works, but it requires some knowledge about programming, or at least some expressions in Cinema 4D. So let's create a noise here. Let's go and make a purling noise, and let's increase my scale. That's nice. Let's turn off the visibility, and let's add some animation here. So there you go, 50, and this is what this does. Now let's go and add a formula modifier. And what the formula modifier does is basically it executes an expression here based on some variables and the very important word subfields. Now I'm going to focus on this. Everything else you'll find out through the help. Subfields is the data that's evaluated before the formula. So in this case, it's what the random field it's giving it. So this is what it sees. So if I say subfields, I'm actually going to select this and copy it because I'm too lazy to type, paste it in here. So subfields, it does nothing. So it takes the same data and just moves on. But if I say subfields divided by 2, now we're at half the height. So I can do all sorts of interesting things. For example, I'm going to do this in end modulo, open parentheses, subfields, and a semicolon, and let's put a 0.1 here and close the parentheses and press enter, and there you go. We can create all sorts of interesting effects by adding a modulo operation to our noise. We will do a lot of examples with a field list that include the formula field, so don't worry. This is how it works. Just take the subfields and multiply them by something. The freeze layer is a bit of a complex modifier layer, so I'm going to give you a couple of hints right now, but I'm not going to go into details because we are going to dedicate a whole video on the freeze modifier. So the freeze modifier actually just records any data that's already available in the list. So I'm going to create a spherical field here and make a copy of it over here, and let's add a, I don't know, a linear field over here, and let's rotate this bugger over here. So we have these three fields that are creating a very particular set of data, and then I'm going to add a freeze layer. So now if I turn everything off, you will see that the freeze layer has that data. It holds that data in memory, and it can do all sorts of things like grow it, for example. So it can grow the data from a certain point, and yeah, it does all sorts of interesting things. How exactly it works, because of course you'll ask me, oh, it doesn't look like it looked before, and all sorts of other things. There are some very fine details and things you need to be very careful with the freeze layer. So number one, it doesn't matter where it is in the list. It doesn't care where it is in the list. It always records the data of the list, the final data of the list. So although it's here, and in theory none of these three had happened, it does record the final state of the list anyway. So a couple of things to remember. Number one, it just records data and then it can actually either blur it out using the average, so we can blur out that data, whatever that is, or we can grow it in some sort of way, so it creates some sort of growing effect. As time progresses, you can see it grows, and we can do some really fancy things. We have a radius subfield, so the radius we have here can change using subfields. And what I'm going to do, just to give you a very quick idea of the usage of it, I'm just going to create a new spherical field. Let me just remap it like this, and let's make it smaller. And let me go and move it over here. Fantastic. And then I'm going to add a freeze. And what I'm going to do is set this to max, set this to normal, and let's go and grow this by maybe 20 centimeters and rewind, press play, and you will see that it does an automatic growth effect. So these are the kind of things we do with the freeze layer. But number one, it doesn't matter where it is in the list. That's the very, very important thing about it. And all freeze layers in your list actually hold the same data, exactly the same data. What they do with it is different, but the data they hold is the same. We are going to demystify all these things in a very particular video about the freeze layer. But for now, let's move on. The invert modifier does what a standard inversion does in all sorts of other software, which is basically it does a 1 minus the value. So let me show you. I've got this linear field in my list and it's creating this ramp, and I'm going to go and add an invert, and you can see that it's inverted around the halfway point. So over here, if I turn it on and off, you will see that that's a symmetry. So basically all invert functions do what I told you already. They do a 1 minus the original value. If this is the original value, 1 minus the original value is the inversion. And it also inverts colors as well. So it's very, very useful. The noise remap has a very simple function, but it can create some interesting effects. So we have this field list, and it's just creating a ramp and pushing up some other cubes. And let's go and add a noise remap. And you see this weird shape happening. And let's go and make the scale a bit smaller. You can see there's a huge addition of noise. So what this does, it just creates a two-dimensional noise. So imagine if instead of a noise remap, we were using a curve. So I think this is the best way to show it to you. If you take this curve, which is linear now, so all the colors coming in are going out, and start adding little points here and creating a noisy surface. Imagine if this was just a two-dimensional noise. This is basically what the noise remap does. It creates the equivalent of a two-dimensional noise like this and applies it to the data that we already have here, and it's based on one of our built-in noises. So you can see the smaller this becomes, it starts to resemble what I was doing over here. So that's all it does. It just remaps the values based on a 2D noise based on these parameters here. The Python modifier, well, you need to know how to use Python to use it. I just add it and press play and show it to you. So this is just a modifier that uses a Python language to control the incoming and outgoing data, and you can actually create your own data sets and whatnot. Anyhow, if you know Python, go ahead and knock yourselves out. The quantize modifier, well, it quantizes the data. There you go, and you can choose how many steps it will quantize it to. Now again, I want to repeat that a lot of these things we can do them on a per field level, but this allows us to do it to the data which is provided to us by the whole list. So if I went here and added my typical random Perlin nice little noise here, and let's put this here, set it to max. Now you will see that all the data is quantized both on the linear field and the random field, because the modifiers, they do whatever they do depending on where they are in the list. And it's a good time to show you that if I put this here, you will see that it only affects everything underneath it. So it only affects the linear field, and because the random field is on top, it's going to be added on top as you would expect. And here is the application on everything. range mapping is a very convenient way to remap our data. So if I go to range map, we have this very simple interface. So when 0 comes in, 0 comes out. When 100% comes in, 100% comes out, which means nothing happens in this case. But I can say that when I have maximum input 100%, I want this to be, let's say, 150. Now don't forget that all this time we've had our list unclamped, so we can see all the values. So don't forget to unclamp your list. But generally, range mapping is good for negating things. So now when I have 0, I get 0. But when I have 100, I get minus 100. So I can reverse my values. So generally, range mapping is a very interesting and very helpful way to remap your values to the ones you need. And the interface is very simple. The remapping is very interesting because basically what it does, it allows you to do the same kind of remapping we can do on any of the fields. So if you go to field and go to the remapping tab and do the contours and the color remapping and all that, basically the remap modifier allows you to do that for the whole list, which makes it extremely convenient. And it gives you a remapping and a color remap with all the functions we know. So extremely useful. We're going to close off this video by talking about this little folder down here. So this folder works just like the layer groups in Photoshop, where you can actually put things inside and only whatever is in here will be affected by its little siblings. So when it's orange, it means that it's not working because there's nothing in there. So let me turn off the color. And what I'm going to do is put the random in here. And I'm going to set this to max. So what I'm going to do is do some things in here, and they're only going to affect the random field. So let's go and add a curve, put it in here, and I'm going to command click here, and you can see that although the curve is above the linear field, because it's within the folder, it only affects things inside the folder. And this is fantastic for creating extremely complex and very, very highly controllable field lists that do exactly what you want with your data. So at this point, we conclude with our modifier field layers and the little folder.